Good afternoon, everyone. Thank you very much, Sukriti. Thank you all. This is the last part of the session, and we were thinking it would be good to, before we wrap up for the day, discuss some of the thoughts, ideas, and have feedback from all the people available here, as well as it is kind of an open house. Everybody is free to pitch in, share their thoughts, ask questions. I have listed down few points. I'll start with them. Feel free to intercept, provide your inputs, ask more questions. Shall we get started? All right. So first thing I had was, like in the morning, Venkat started that we should aim to be a polyglot programmer. We should not be constrained with just one language. What are the two other languages which our panelists feel, apart from Java? I assume most of the people here are Java programmers. So I'll start maybe with Naresha. What do you think would be the, two other languages according to you, which are interesting to learn for all of us here?
Before I answer that, by the time during when I was graduating, generally my opinion was that you should choose one language. So I would summarize it as the idea was like flirt with all but marry only one.
All right.
But then,
does your wife know about this?
Or we can say flirt with all and marry with none.
You know where he's going to sleep for the rest of the week.
So, but then recently I realized that that's not the reality. You have to, work with multiple programming languages. So.
You need to think before you choose analogies.
So today I would say one would be Groovy, which offers a lot of productivity benefits. That's why you could pick Groovy as one of the languages. And my second pick would be still in JVM would be Clojure. So Clojure is more coming from functional paradigm, and I think it would be good option for a certain set of problems. So my pick would be these two.
Maybe next can be Deepak.
Sure. So the question was other than Java?
Other than Java.
Okay, so but if you're not using Java, then so I don't use Java at all. So I'll try to answer it by saying that Groovy is my primary language, So I'll try to answer it by saying that other than Groovy.
All right.
Yeah.
So you have three choices now.
Yeah. So of course, other than Groovy, if I have to go back, start my career again, I have to choose one language. Probably it would be JavaScript, because of the ubiquity that it runs on the server, runs on the browser, and just that there's so much momentum around it these days. Apart from Groovy, JavaScript, I'll probably look at Python or Ruby, but I'm not sure. But I don't know about these languages, but I think that these are good languages from the code samples that I've seen. They look pretty readable. There is good community around them. There is adoption around them. And there are people who, thought leaders speaking good about them. So apart from Groovy, JavaScript, I'll probably look at Python or Ruby.
All right. Thanks, Deepak. Kunal, what would be your thought?
Anyways, I am quite loud any which ways. So, for those, if the question is from the perspective of Java developers, and if they have to start another language, Groovy is definitely the one that I would highly recommend. That you start with that. That gives you a hang of how duck typing in Groovy works. You can still latch on to your type safety whenever you want to, but get a good sense of how dynamic nature of language, metaprogramming and things can be done. Otherwise, Ruby is also a good option, but this is one side of languages. Now it depends on the type of person you are or what type of language you choose. But I would highly recommend Scala because it opens up a different way to look at type safety. Because we usually assume type safety means a lot of boilerplate code, and that's not the case with Scala. So you could definitely give it at least one shot and see at it. Just to get a perspective, I personally have coded in Scala. I don't like it much, but I'm openly saying that it is very good language to look at. It is complicated language, but yes, if you are not TypeScript kind of person, I would say try JavaScript because it is very loose language and you can mold it, and there are potential pitfalls that you should watch around for. I am currently working on a lot on JavaScript and CoffeeScript, which is a transpiler for JavaScript. So I'm not directly using JavaScript, but CoffeeScript. But the ubiquity is the key thing there, that whatever way you are coding for browser, for server, or any middleware, it still works. So those are my options.
Right. Thanks, Kunal. Venkat.
So I think we got some really good advice, both on social life and as well as on programming. So I want to, rather than reiterating that, which were really good advices, I'll take a slightly different view on this. So let's leave out the languages for a minute. Let's say we're not interested in picking another language. Then what should we really look at? So one of the things that I realize is either you love static typing or you hate static typing. And I think both of those views are completely flawed. We cannot love it, we cannot hate it. It's practical in certain ways, but at the same time, there are limits to it. So from that angle, if you are interested in static typing, and if all that you have done is program in languages like Java, you really don't know what static typing really is. So like what Kunal said, you want to go look at languages that do implement fairly good static typing. So from that point of view, I would say, spend some really good time looking through Haskell. Because when you look at Haskell, Scala really takes a lot of its static typing from Haskell, and Haskell implements what's called polymorphic type. And polymorphic type, it's really insane even to use the word generics, because Java has completely corrupted generics. But it's really where you can define a particular type, but the real type is inferred on a context at compile time, and it really opens your mind how that works. But more important, while Haskell is statically typed, 90% of the time, you would never actually say what the type is. It feels like being in real love, right? You don't have to say it explicitly, right? You get it, right? And that is kind of the way you feel. It's like, wow, it's statically typed, but I don't. In a really good statically typed language, you actually do a lot less typing with your fingers. And that is one of the things you will see in Haskell. Then when you say, okay, all right, we looked at static typing, but what about metaprogramming? Well, if something like metaprogramming is interesting to you, definitely Groovy offers metaprogramming, but Groovy's metaprogramming has been built and rebuilt over years. But then you go look at metaprogramming in Ruby and you see how clean it is laid out in front of you. And JavaScript has metaprogramming. Python has metaprogramming. Almost any language that's dynamic type today has metaprogramming. On the other hand, Scala says, well, we'll give you a limited metaprogramming by having implicit classes and implicit functions, and that's just a different take on it. But not only that, you look at compile time metaprogramming, you don't have to use something as complex as AST transformations or aspect J, but you could use something like AST transformation. So that gives you a very different angle. And a third thing to look at is, hey, if you're doing multi-threading, if you're doing concurrency, how difficult it really becomes to deal with managed state, shared mutability. Well, then you start looking at STM, software transactional memory. And Haskell introduced software transactional memory, and Clojure has STM on the JVM. Multiverse is a library on that provides STM on JVM. And then you realize, oh, look, we don't have to suffer through the shared mutability. We could use something like STM. Or you say, well, I really want to isolate my mutability. Well, it turns out Erlang implemented the actor-based model, and Scala took Erlang's actor-based model, and then Akka and Scala implemented really well. And there are so many libraries on the JVM that does actor-based concurrency. So to me, the languages are not gateways to syntax. Languages are gateways to paradigms, different styles, different thought process. And so the reason we want to go look at these languages is not to see what kind of syntax they provide, because that's the least interesting parts of languages. The idioms the languages provide, the way they bend your mind, the type of style of programming you start implementing with them, and then you can come back and say, well, that's all great, but how can I do any of those on the languages, in the languages that I'm programming? And almost every single one of them I talked about, you can actually do it from Java. But it's just that you have to start reaching out to different libraries and different styles of programming. I think that's the real fun part. So rather than looking for a language, look for styles, paradigms, idioms, and say, and also pick a language that's so very different. The language that you are picking up should hurt your mind. It should make you cry. To me, learning is like peeling an onion. There are two reasons why I compare it to peeling an onion. One, when you peel an onion, I don't know why you would do this, but if you peel an onion, there are more layers to peel. And then you peel some more, there's more layers to peel, right? And then until you get to the real small, part of it, there's layers to peel. But there's one other thing that happens when you peel onion. What is that? You cry. If you're not crying enough, you're not learning, right? And that's why it's like peeling the onion. You need to have that both. Both the experiences are important, I think.
Thanks, Venkat. So I just wanted to know, how many people have tried Haskell here? So we know which onion we want. All right. Apart from two, we know which onion we can peel. Try to peel in coming days. All right, moving. Anybody has anything to add here? All right. I had second question in my mind. One, so last year Java 8 was released, and I guess there are a lot of new features, and it's kind of rebirth of a language, one of the strongest push towards its revival. What are the key areas one should put efforts in learning in Java 8? We'll start with Naresh again.
Again, I mean, the perspective I have here is...
Social perspective again?
No, not really. When Java 7 was released, I mean, it was about to be released, I was eagerly waiting for it to be released. I was telling to my colleagues what other features are there and all. Finally, it got delayed and delayed. So that was the problem. That was the context I was in. But when Java 8 was about to be released, I was already using Groovy for my day job, and I was not really waiting for any of the features there. So my point of interest would be, as a Groovy programmer, what would be the interesting features for you in Java 8? So the first one I would say is Streams API. So generally people would say lambdas, but since I was already using lambdas, I was not requiring that. But Streams API is something which will add value to Groovy programmers. You can really call Streams API, and instead of lambda expressions, you could pass Groovy closures there. So the real benefit you would get is the lazy evaluation what Streams API provides, and also it improves. I mean, it improves file API and all. The same benefits it will bring onto file API, the NIO2 as well. Second one is one I would say, to a smaller extent, datetime API, which otherwise I would really use Yoda time library in all my Grails projects. So now I directly rely on Java 8 datetime API. So my pick would be these two. And actually, another interesting thing is the way the Java 8 lambdas are implemented. Instead of that inner class, that additional file, the way they incorporate into they store it in the same file, essentially using the invoke dynamic, which was really intended to be used by JRuby, Groovy, etc. But the language which took real advantage of that is Java 8 itself. So I would say those three.
Deepak, you would like to add something? Or you have stopped
I
using
already
Java?
confessed that I don't look at
All right.
Java.
Kunal, you still use?
So it's been a long time since I used Java as such for the project. I just keep a tab on what's going on there. But what Naresh added, I don't have much to add on top of that. Streams, as he said, is actually a nice thing because it's not just a regular collection processing which happens in step by step. It is lazy and everything happens at the end of the computation. So it's quite interesting, and if you have not checked it out, I do definitely recommend that. That's all.
Thanks, Kunal.
I think Naresha pretty much summed it up. So I think every point he made absolutely is useful and valuable. So I would say when it comes to Java 8, rethink the way you program. What about programming with fewer states? What about programming with immutability? What about writing pure functions? What about reducing side effects? And then you start developing code where you start composing your methods by taking a data from one particular evaluation to the next one, to the next one. Sometimes you call it a builder pattern, sometimes you call it a chain of responsibility pattern, whatever you want to call it. And then it starts changing the way you start writing code. And then you realize, oh, wait a minute, not only can we do this, but some of these evaluations can be lazy evaluations, which means that if I don't have to perform a computation, it doesn't spend its time running those computations. And then once you get a hang of the lazy evaluation and parallel computation, then it changes the way you start using the language. I've never been excited about Java as much as I am when I look at Java 8. And it's just amazing in terms of some of the things like what Naresha said about how invoke dynamic is implemented, how the stream API is built. But that's just a starting point to say, oh, this is going to be different. So the question then is, hey, the API, the stream API, so what's the biggest change? I'm going to say the biggest change in Java 8 is actually in the minds of the programmers. Because you would have to reprogram, you would have to rewire the way you start programming in Java. And as you rightly put, it's a very rebirth of a language. And it is so significant because it's not a whole lot of syntax. You can pick up the syntax in a matter of hours to a day, but changing the paradigm is the most difficult. And we need to sit there and say, how do we really program this in a very different way than we are used to all these years? I think that's where the challenge is, but I think that's where the fun is as well.
Thanks, Venkat. Thanks, everyone. Anyone here would like to add some of the features which they really liked or disliked in Java 8? Yeah, Uday, go ahead.
This default interface implementation, is Groovy is also going to implement that kind of feature, or they are already going to have these traits? So is there anything going on for that? Do you have any idea?
So with Groovy, there are a couple of things going on in Groovy. And one of the things, first of all, Groovy has to implement everything that Java implements. That's the first thing. And the reason for that is Groovy, all Java code is Groovy code, more or less. So from that point of view, Groovy has to do a little bit of a catching up to what Java 8 provides. However, one thing I really see in the Groovy community, which is a nice thing, is they're not so as eager to say, we're going to re-implement certain features in Java that are available already in Groovy. Rather than doing it, they're going to provide a direct support for those, but then they're going to find out ways to improve fluency. A way to think about this is, if you look at the JDK collections library, you have array list, you have hash maps, what have you. Languages like Scala go off and implement their own collection. Well, Groovy don't have any collection at all. But what Groovy did back in time is it introduces the Fluent APIs on those collections. Now, of course, a lot of those are redundant with Java 8, but they're trying to do exactly the same thing again by rethinking through Java libraries and say, what are the places where fluency is still missing? And they're trying to make those things more groovier. So from a Groovy point of view, you get double benefit one more time. You can use Java 8 in Groovy, but it can be more fluent using it again. So that's kind of the direction they're trying to take.
But as a programmer, there will be two kind of a programming. One person is doing the programming in traits, one person is doing the default interface implementation kind of a thing. So I think it's going to be difficult and going to be more different kind style of coding?
Well, the assumption there is that somehow default interfaces are traits, but they really are not. They are extremely far from traits. Traits give you the ability of stackability. Default interfaces don't. And so as a result, while default interfaces are a way for you to evolve existing interfaces, traits are really about stackability. And Groovy provides stackability of traits, but Java doesn't. So they're not really the same things.
Anyone else would like to add?
I think, sir, with Java, we easily implement reactive programming with Java.
How so?
When I attend your VJUG presentation about reactive programming.
Right, but remember that's nothing to do with Java at all, right? It is really a library that you are using.
Reactive Java.
But any library on the JVM is usable from any language on the JVM.
But with lambdas, we easily use with lambdas or string.
And there is no language on the JVM that doesn't have lambdas today. So the point is languages have no consequence anymore in that regard, right? Any library on the JVM can be used from any language on the JVM, and every language on the JVM supports the features of lambda expression, so you could write it on any language you want. So language is no longer a barrier in that regard.
I think this is one of the points which we have to always keep in mind. JVM as a platform is very, very stable, mature, and powerful. And if you remember, one of the slides in Venkat's first presentation was Java is one of the weakest link in the platform, and which is in the process of time will tell with Java 8 how far we reach. All right. Going to another level of abstraction, we talked about polyglot language, polyglot programmer, multiple languages. We have, on similar way, multiple application development frameworks. We talked a lot about Grails, but there are many others. So I would like to hear your thoughts about how would one go about choosing, frameworks like we have Mean, which is getting more and more traction. There are many others. So again, let's start with you, Naresh.
Well, again, I don't think there is any silver bullet to select that exact way. Or I would say each one's need would be different,
Right.
one. And need might be different from yesterday for the same person, could be. And also that framework will evolve over a period of time. And considering...
I'm sorry, but all I can keep thinking is, do you flirt with frameworks like you flirt with languages too?
That's not really. One of the questions I keep getting, people ask is like where Grails is relevant and where Grails is not relevant kind of thing. Generally, you take this, a common scenario of a web application. I would say where Grails would really give you productivity benefits is when you have a lot of functionalities used by maybe different set of roles, what would say, than when you have very few set of, features used across, used by lot of users. It's like, say, chat application, if you take, 10,000 users may be using that, but they're all doing the same thing. So there, you may not have a lot of productivity benefits by using Grails. Whereas something like Node.js or anything in that style, like which doesn't use single thread per request model, would be a better choice. Whereas you have a lot of heterogeneous data to deal with, Grails will offer you a lot of productivity benefits through its GORM and various. The GORM itself is an abstraction for it could be for say relational database, or it could be MongoDB, or even recently Cassandra as well. So that way, I think that's the main aspect I would say.
Yeah. So over last 5-6 years, as part of IntelliGrape, we have adopted certain frameworks, and we have, given a pass to certain frameworks. But I don't think there is a science around that. But still, I was kind of thinking what are the things that go in my head when when we think about a framework, whether we should invest on building skills on top of this framework. So of course, as a service provider, we need to look at adoption. If there is industry momentum, if there is a reasonable adoption around that, though we adopted Grails when it was 0.2 something, so I'm contradicting myself. But as of today, I would like to see if there is some momentum around that. Because there has to be a community for a framework to grow. I mean, you can't just, there might be things which are great, but if there's no community around that, for example, Ruby comes to my mind, that Ruby was always a great language, but but when Rails came, then, Ruby became great, got adopted, and then that was the right time for people like us to invest in Ruby and Rails. So one point is momentum or adoption. Then there have to be people like Venkat who are speaking on that, then you can be assured that, okay, now this is a good platform, and if there's somebody thought leader, but I'm serious around this, because if Venkat speaks, then it's like self-fulfilling prophecy that Venkat speaks, and then it becomes popular, and then it grows, something around that, You can replace Venkat with somebody else as well, but there has to be, again, it goes back to the idea of momentum and adoption, community thought leaders. Then, of course, as a developer, when I try to use it, I see it. Does it feel good? Does it feel neat, elegant? And that I can't explain, but when you just look at it as a developer, somebody who's working on the framework, on the building blocks, will he feel good about using that, or doesn't feel elegant? I don't know. So that is another aspect that would come to mind while choosing whether we should go after this framework or not. And third is you look at the building blocks. Like if the building blocks are good, when we looked at Grails, then it was Spring, Hibernate. These was some of the things that we had been working for a long time of giants. So that is like you look at the building blocks. So I think these are a couple of things that I would look at, but it's really not a science, probably. Yeah.
So I'm not really a framework guy. I hardly work on or hardly know about frameworks. Honestly, I have just used Grails for some spikes. At daytime we were using Play for some time, but that also I am not much into frameworks. And honestly speaking, I don't like frameworks as such because they get into your way at some point or other. Not to say that you have to reinvent the wheel all the time. That's of course not the way to do. But like in Clojure, there is a philosophy of like always having composability by means of having libraries and not frameworks. And that is actually really good way to go. And personally, I always like that I can choose routing of a different framework, whereas persistence of a different framework, and maybe templating of a different framework. And they should not force me to choose one thing. And most of the frameworks these days have a capability of swapping implementation. So I'm not saying that frameworks are bad. Again, coming to my choice, if I have to, it really depends on application that I'm trying to build. It depends on the team that I already have. It depends on the skills. It depends on the runtime of that. How are we going to use? Currently, I'm working on an app that is purely client-side. I don't even have to think about server-side framework. We are building a no backend kind of JavaScript app. So they become easily like no-brainers for us that server-side framework, I don't even have to care. When we need it, we will think about it then. We just defer that decision. For smallish apps and those things I really like, that utility app that I can quickly create and just throw and see on maybe on Google App Engine or Heroku or somewhere deployed. I like Sinatra a lot for that. It's very elegant, very small, and I could still get my stuff done. But it was some time back. So those are my opinions. I know that I'm not throwing any light on any particular framework, but that's what my personal opinion is. Thank you.
Thanks, Kunal. Completely different opinion, but yeah, poor.
I think that those are very interesting thought process, to be open, to look at things. And as Naresha also said, how do you decide what is the right tool to use? And if you really think about the words that you heard, it's a little bit shocking, isn't it? The word that you probably heard the most was the word feel. It's not very scientific, as Deepak was saying, right? And that is something that I think we should, as developers, begin to quickly learn. When a particular problem is given to you, how does this feel? You should have a way to know, does it feel like Grails is the right choice for this? Or does it feel like something else we should use, right? So for example, I had to build something which is going to take me a very little time to build. And it served one very narrow specific purpose. And it is extremely simple to implement. But then I said, I know how to exactly program this in Grails, but the mere thought of the number of files I have to upload to the server felt this is insane for the problem I had on my hand. And I quickly realized, you know what? I could write a little node script, one JavaScript file, and I could run this one file and get my work done. And at that point, I've never, ever written a JavaScript node server. But I was convinced that Grails is not the right answer at this moment for what I had on hand. So it took me another extra 30 minutes to figure things out. It was exactly 15 lines of code. And it's been in production for about 4 years now. And every time I go to that server, I laugh at myself. Thank God I didn't do anything else, right? And so you need to ask yourselves, for what I want to do, is this the right tool? So there are two things to think about, right? How do you know what's the right tool? Well, you don't know. And the worst thing you can do is go read up on the blogs and say, what are the laundry list of things, right? Well, to a certain extent, it's a good thing to know that. But those are not very reliable. So to your point, right, we got to prototype. So constantly be prototyping. Every week, every month, your part of your job, part of your time should be to prototype. Hey, I heard about this technology. I use a 3-time hearing rule. I heard about this once, heard about it second time. I heard about it third time. Now it's time for me to do a quick prototype. And when you do that little prototype, you're not committed to it, right? To use the wisdom of Naresh, this is like the dating, right? You're not committed yet. You're just exploring, right? Hey, check this person out. That's all you're doing, right? So you just do a little prototype, you get a feel for it, and then you say, oh, here's the strength, here are the weaknesses, here are the things that it provides for you. And now that is in your knowledge portfolio. And then later on, when you have a problem on hand, then take the problem and do a quick prototype. If you go to your company and you tell them, here's a different technology we have to use, the first thing they'll do to you is to reject it. And they'll say, no, don't do this. Or even worse, if you go to a bigger company, what do the bigger companies have? They have what is called architecture committee, right? You know what an architecture committee is? That's where innovation goes to die. Because you go to them and say, I got this great idea. They say, write a proposal. And 3 years later, they say, we are considering it. The world has moved away, right? So come up with business reasons to do things. Don't go to them and say, here's a cool thing. Here's an acronym I want to use. Instead say, here's what we have. Here is the cost. Right? I had an opportunity recently where a client wanted to use a certain technology. They called me and said, this is what we're going to use. And come and help us with this. And I went there with exactly the same idea that I'm going to help them use this. And once I went in there, I said, what is the problem you guys are trying to solve? Well, this is what we're going to try to solve. And I looked at this and said, if you're trying to solve this problem, why are you using this? You got the wrong guy. I shouldn't be here helping you guys. A better solution is this other solution. So go hire people who can help you with this. You don't need me. And they send me a thank you email saying, wow, we were going in the completely wrong direction. And you asked a very fundamental question. Why are you doing it? And we have assumed that this is the answer, and we were trying to go solve the problem, right? And that is something each one of us, that's our professional responsibility, right? Professionally, each one of us, it doesn't matter what your title is, but it's your responsibility to ask the question, why? Why are we using this? What is the benefit does this provide? And then if it is the right solution, and I would rather spend a little bit more time and money learning something that will make me more productive in that than apply a wrong technology to solve a problem. And that's why we got to constantly be prototyping, constantly learning. And that is why we are professionals, right? When you look at doctors, you would not want to take your kid to a doctor who says, I got my degree in 1960, I don't need any stinking knowledge anymore, and I'm going to keep prescribing the medicines I know already, right? That's not the doctor you would put trust of your family. You want a doctor to be constantly talking to medical representatives, learning about drugs, learning about side effects, and turn around and ask the question, we are that professional in our own field. It is our responsibility to keep investigating, learn what's going on, and then be agile about changing. And I think that is the most important thing. It's not what we choose, but to have that ability and the wisdom to choose that I think is more important.
Venkat discussed about like TDD is like an exercise. We all know both of them are good, but we really get into the habit. So if I have to ask quickly each one of you, what is one thing apart from TDD you have felt like strongly passionate about that has improved productivity, or you have seen productivity improvements in a significant manner, and you would like to recommend that? That would be really interesting for all of us to hear.
One principle which I found it really, really beneficial over the years is dry principle, I would say. But I hope you know what it is. Don't repeat yourself.
What is it?
I don't repeat myself. So, but what we have to understand here is that most of the times dry code doesn't get written. You have to make the code dry. So it's like you may have to allow duplicate at once, and then you find that things are going in the wrong direction, and you have to clean up through refactoring, essentially. So that's one principle. If I have to pick, I'll pick that.
Yeah. So whenever I look at a programmer who is using the mouse, I feel like slapping somebody. Yeah. So this is something that I'm really, really passionate about, and I really, I've stopped doing that, but I feel that as programmers, we should be very, very, productive with the keyboard. Try not to use the mouse. Even with browsing, there are some awesome plugins that we can use for mouseless browsing as well. So, try to keep the mouse away. I think it takes away productivity.
Yeah, especially when we are working on IDE,
Yeah.
we should really remember all the shortcuts, which we use, and it really helps productivity boost in an enormous way. Just give it a try. Whenever you have to use mouse, try to spend a couple of minutes, or if it takes 5 minutes, to find what is the keyboard shortcut.
So some of them, they're plugins with different IDs which allow you to, whenever you use the mouse, they'll prompt, okay, this is the shortcut for that. So one of the things that I've done practically is I use my right hand, but I've put the mouse on my left with the left hand. So it takes a little bit more time for me to use the mouse. So it really so I make the mouse more difficult.
Right,
so,
right.
Something that I've tried and it really works. So.
All right.
Second, I think that each one of us should be proficient in something like TextMate or a VI or a Emacs kind of editor. So not a full-blown editor, but a console-based editor. That really helps. So that allows us to log onto a server and not complain about, okay, I don't have my ID, therefore I'm feeling lost, saving file, instead of saving file, I've deleted file, things like that. So, because when I've seen that some very good programmers, when they move onto the server to do some quick fix, they feel lost. So another thing, So I feel that one should be really, really proficient, almost as proficient with their main ID like IntelliJ or IntelliJ IDEA or Eclipse, as with a console-based editor like VI, Emacs, TextMate. Then, it's a mindset thing, like you were talking about Drive, which is more of a principle. So being ruthless about our own code, like refactoring it, not getting attached to what we have written. In fact, if we think that we have written the best, we should keep looking back at the code that we have written 6 months back, and if we don't feel that it stinks, that I see that as a sign that we have not learned much during last 6 months. As in, we should feel that, okay, no, this is, I could do it better. This is what I've written. Otherwise, if we are not able to think of a way of doing it better, that probably is a signal that we have not learned many new things. So ruthless refactoring is a mindset that we should all have, and that will help us being more productive. That's what I feel. Thank you.
So apart from TDD, if I have to see something, so my opinion again, there is bit different. TDD does not make you more productive at first. You are in fact, you feel that you are slowed down because of that. Just think in terms of maintainability. When you have to come back to that code after 6 months, it is really then you start to see the effectiveness of that. Now, just not that TDD as a testing itself, but what do you write in assertions and what your description of the test, they are also very important equally. But if we have to completely skip the testing part, what I would say is that, and it is on the same lines, that to be more productive, you have to master your tools. For example, choose one tool. I, for example, like IntelliJ IDEA, and I'm not forcing that on anyone, but the thing is that you should start learning how to use that effectively. Second, start using Unix or Linux-based systems more and more. Script all the small things that you can. You don't have to write a next big thing. You just automate how you clean your desktop, how you do things, how do you move your files around, how you tail and grep on a log, how you find phone numbers in some text files. Prefer text files more than anything. Don't write Word docs and PowerPoint and Excel and this and that. Markdown is ultimate format that you'll ever need to write blog posts or do whatever documentation. Always write a README file. Maintain your dot files. How many of you maintain dot files? Cool. Have your dot file repo and last advice that open it up. Open everything. Because the worst thing that we do is to keep things with ourselves. And we have fear that I write bad code. I still write bad code and I know that it is available to everyone and everyone will comment on that. Trust me, no one does. Nobody cares about you. There is a ton of code online already that is available for everyone to watch. Nobody is going to see your code. But if one guy who issues a pull request to your project, you will feel good about it. That, oh, someone has actually used my project somewhere in production. And trust me, even if it is, he say, no one, just think of yourself. Will you say someone else's code and just say that, oh man, you suck? You won't say. You will say in a subtle way. Same thing people do to you also. So don't worry about that too much. Just open it up. That's all.
Venkat, you would like to add something?
Really interesting. So I'll actually say there is a principle, the practice that I use actually more than TDD, not just in addition to it. And this is something I learned fairly early on in my career, and it's opened my eyes. And that's going to be code reviews. And even today, I practice code reviews quite extensively. And just to share with you an experience, I was on a project. We were about 15 different people working on the project. And one of the people that I was working with, a supervisor at the time, said, we're going to do code reviews on every single line of code that ever gets written. It doesn't matter who the person writing the code is. You don't have to be a senior developer or a junior developer. You write code, it gets reviewed by somebody else. And we were a small team of people at the time, and within this bigger project. And we would spend our time reviewing each other's code. And while we did this, the rest of the team would literally be laughing at us. They would look at us and say, look at these guys, rather than getting the work done, rather than writing the code, they're wasting their time reviewing the code. Well, once that particular iteration or release was over, literally the number of bugs in the entire application was in thousands. The number of bugs in the part that we wrote, where we had done code review, was, you could count them with number of fingers in your single hand. And while the rest of the team was spending the next 6 months fixing bugs, we had moved on to implement several other features for the next version. And I was convinced at that time. And so to me, code reviews are extremely important. However, anytime you mention code reviews, people really get angry, right? They don't want to do code reviews. You go to a company and you say, I want to do code review. The boss says, code review? Is that what you guys do? Like on a Thursday afternoon, everybody gets into a room, You project the code on the monitor and everybody starts talking. That's the code review. It's like, yeah. Well, no code reviews for you. Like, why? Because, Joe says, look, I don't want to be wasting my time looking at the stinking code this other person wrote. I've got other better things to do, right? In the meantime, the guy who wrote the code says, I don't want to get criticized in that room. I'm going to call in sick that day. In the meantime, the boss says, oh, code review. The last time you guys did it, there was a fight. We had to call the cops and one guy quit. No more code review for you, right? So it becomes extremely political. Nobody wants to do code review. But it's to the contrary. The way that we do code reviews is we call it tactical code reviews. So I write a small task. As soon as I'm done with the task, you are responsible to do the review of that code. Just you, that's it. The next task I work on, he reviews it. The third task I work on, he reviews it. And then I rotate it among these 3 people. I don't invite a team and hold a meeting, right? It's just a tactical code review. Likewise, the code he writes, I review it this time. The code he writes next time, you review it the next time. And then so we rotate it. And also we have this policy where you cannot say I'm too busy to review code. Well, somebody writes code, it's part of your responsibility to review the code. And if you're too busy to review code, well, quit writing other code and take time to review other people's code. And if you want to really take it to the next level, well, you can do pair programming. And if you do pair programming, you have an instant active review of the code right then. But if you do this, I recommend you don't pair with the same person for a long time. We rotate pairs on a daily basis. If I pair with them today, I pair with you tomorrow. Then we don't get into this pattern where 2 people get together and write the crappy code. You are able to really improve the quality of code over time, right? And that can be another way. So if you ask me if there is one practice that I follow, anytime I bring in projects to implement, that's one practice we follow. Either we do pair programming or where we are way too remote in different time zones, every single line of code that one person writes, another person reviews it. And that has a huge impact on so many levels. It removes so many bugs even before the code goes into production because somebody else who is reviewing it. But be also very careful. Don't go bring somebody who doesn't write code and tell them they have to review your code. That's dangerous. There's a name for it. It's called priesthood-based code review. These are priests. They have a big beard. They say, when I used to write code 20 years ago, like, no. Are you working on this project? No, I don't write code anymore. Then don't review the code, right? Well, it should be people who are writing code actively on your project who should be reviewing code. Then there's a context, there's a perspective, and then the number of bugs gets lowered. The other benefit is, you talked about refactoring, which is extremely important. Somebody looks at this code and says, hey, look, this is 70 lines of code. It failed single responsibility principle. You got to break it up. Or here is so much duplication, we can roll it up. How many times have you written code and somebody looks at the code and says, I don't get it? If you want to make code readable, there's only one way to make code readable. Read it. If nobody has ever read your code, and you say my code is readable, what does that mean? Nobody has ever read it, right? There's no human who has survived reading your code, right? Then they cannot claim it's readable, right? So readability comes from reading the code actively. And how do you name variables? How many times have you seen variables called P, Q? Do you do this to your children? Son, what's your name? P? Is it your initial? No, that's my full name. Why did you have that name? Because my dad is a programmer? Right? You don't do that, right? You give nice names to your children. Then why do you do that to your variables? If somebody else reviews your code, they're like, okay, P? Really? What is that for? Why don't you enlighten me, right? The other day I was reviewing some code. It said RQS. I'm like, okay. Interesting. I don't have a clue what RQS is, but the guy who wrote it knows it, right? How many times you look at this code and you're like, I don't know what this is doing, right? So we work in a field called software archaeology, right? You look at this and say, when this guy wrote this code, he knew what this is. Why don't you go ask him? He's dead, right? And we are trying to investigate, trying to find. We shouldn't be in software archaeology, right? So have code reviews. I love code reviews. And do that through either pairing or do that through, tactical code reviews.
think I would also like to add my thoughts, like pair programming is also having an added advantage that once you get a new person on board, then it is a very seamless way to do the knowledge transfer. And second advantage which pair programming gives is built in a sense of collective responsibility and collective ownership in a very seamless manner. Otherwise, we get into these silos. Oh, this ORM layer, this is my area. This service, this has been done by that person. I'm not going to touch it. When you keep on rotating pairs, then everybody is aware about many areas of the code. There might still be experts in certain areas, but everybody in the team will still be very confident about touching different functionalities, and over a period of time we will see a much more homogeneous team rather than architects, senior software developers and software developers and testers who is, all right, we don't talk to each other. So, all right, we are running short of time, but I still feel these two questions might be interesting for a lot of us. There are a lot of Java programmers here. So how would you feel, if people would like to get into Groovy and Grails, how easy or how difficult it would be for people to get into, these kind of...
I think first of all, the developers should not be branded with frameworks or languages.
All right. People who are using Java earlier, only one language.
Yeah. No, a good programmer can be, a good Java programmer can be a good programmer in other languages too. It's just a matter that he has to understand why the other language exists at all and why did people create that and for what purpose people are using it. I think if you understand these basic questions before you start coding, then that will give you a good direction. Then it's all about to understand the paradigm. Say if you are learning Clojure, then it's about functional paradigm, immutability. All these are very important than just writing any program. So you have to write program from that perspective. So have a reason why you are learning some other language, first of all. Then start with any language. That should be, easy. Should never be difficult. Of course, it will take some time to become a good programmer in that language, but should not be a problem.
Yeah. So I'll narrow the scope to saying that, okay, Java programmer who sees the light with Groovy and Grails and now wants to use Groovy and Grails. So how long does it take for him or her to become as productive with Groovy and Grails as he was with, let's say, Struts or Spring MVC or whatever other Java web framework he was using? So I would say in less than a week, you should be as productive. But to become an expert Groovy Grails programmer, it could take anything from a month to 2 months. I'm giving a very generalized answer, but I've seen it over more than 50, 60 people during last few years that you could be productive, you could be producing something in less than a week. But to be called an expert, anywhere from 1 month to 2 months.
All right.
So for Java programmers, it's not at all hard. It's very, very seamless. Transition from Java to Groovy and Grails, it's not a steep curve. It's pretty comfortable. And in terms of time, 1 week to 2 months.
It's good to know that the learning curve is not steep because sometimes we get a bit frustrated in case it takes a lot of effort to get into something tangible. Kunal, you would have some thoughts?
So for as far as I am concerned, I started Groovy long back, and I really started learning it using Venkat's book actually. So that's why I told him today also that I'm just feeling so lucky to be with you today because I started my Groovy's journey with your book. And Groovy is actually really very easy, and to a Java programmer, to be precise, it is the most logical step that you can take. If you don't want to have tears right now, as if you are to learn something totally new, then probably Groovy is not something that you are looking for. But if you want to get productive, so I can guarantee that it is the most closest language to Java, while at the same time you can give a lot of, like you can get a lot of productivity benefits by eliminating boilerplate code, by learning a few tricks here and there. As far as Grails go, I'm not the right person to answer because I myself don't use it a lot. But whatever prototypes that I have made and whatever things I have used with it, it looks seemingly very easy to me. So compared to Java, again, it would be fairly smooth transition. That's what I think. But just for Groovy itself, I would say that Grails is the right choice to make for a Java developer and to be productive as soon as he can.
So I think I did, and the first thing I would say is, so a lot of us do not learn significant things in a short time. I think we learn in increments, and our mind is very peculiar. And what our mind does is, so there's a reason why when we are children, the rate at which a 5-year-old, a 6-year-old can learn, why do we feel like when we are beyond what age? 30? Okay. Okay, all right. So, I was hoping you would say 75, but okay. So, when we are past about 23, 24, why does it become so difficult for us to learn something new? And this is something that I spend a lot of time thinking about, right? There are days I wake up and I ask myself, am I too old for this? My children remind me constantly. My son would come to me, put his hands over my head and say, "Daddy, do you know how many silver hair you have?" And he would say, "You're very old." And sometimes you feel like you can't even get up and walk anymore, right? And that's when you begin to think, am I too old? Can I not learn anymore? And I'll tell you that's actually not true. And the reason for that is the mental agility is amazing. And the rate at which you can learn is really proportional to how often you keep learning. And that is why I think if we can spend our time every single day doing something completely different from what we do, right? Well, what if it's really hard to get out of the comfort zone, what if we make every day, or at least part of every day, uncomfortable? Where we learn something entirely different, entirely new, a different library, a different API, a different way of solving a problem. And then it becomes a rather very easy. And one of the things I want to get to the point where is, when you see something that is very different, rather than asking, what is it? What if we start asking, how does it compare to something else we know? Then the time that it takes to learn becomes extremely small. So I think one of the best ways to learn something different is to actually be learning something different every single day. It doesn't have to be big. It doesn't have to be where we spend hours and hours. One of the things I used to do when I had a full-time job is lunch hour is my time. Because nobody really wants you to talk to you when you have your mouth full, right? And I always had lunch in front of my computer or in front of a computer magazine. That 30 minutes was my time, my reading time, my time to play with tools. And I would always wake up early in the morning before the family gets up, before they have your demands on you. And then go, experiment, play with something. A little code you want to write, a little library you want to learn. Wake up early, wake up an hour early. And I know in the beginning it's a little hard to think about it. But what if you start waking up an hour early every single day? I wake up at the same time every day of the week. My time starts about 3:30 in the morning. Every single day, 7 days a week. There's no weekends for me. But when you do that, what happens? You wake up in the morning and say, hey, I want to experiment with this. I want to play with this. And there's nobody to talk to you at 4 in the morning, right? And you can play with any technology the way you want to. And that places you way ahead of the curve than anybody else could imagine, right? And so it is a constant learning. I can't really emphasize the need to continuously learn. We cannot take a lot of stuff in a short amount of time. We're just not capable of that as a human being. But we are extremely capable to take a little bit of this delta every day. And so give yourselves that time. 20 minutes a day, 30 minutes a day, is an investment to yourself. That's what you reward yourselves first, right? You know, and this is one thing I want you to think about. Most of us, unfortunately, are like candles, right? You go to the store, you buy a nice candle and say, here's a beautiful candle, and you light it. And what happens to the candle? The candle keeps burning, it gives beautiful light in the room, and after several hours, if not days, the candle kind of goes all the way down and goes flip, and the candle is gone. Do you say, that was a great candle? I will live in darkness since now because the candle is gone, right? No, even before the candle is gone, you're going to light up another one. We are that candle in the companies that we work in. We are there because we produce light. But as you produce light, you're burning yourselves as well. And the only way you can stay is by recharging yourselves, right? And that is the reason. If you spend 8 hours, 10 hours, 12 hours working for a company or a project, and this applies to you and I as well, because we work for somebody else too, right? We are serving our clients. And what happens at the end of that time? Unless you have the next thing you can work on, you and I have no value in the marketplace. And the same thing with employees as well. And so that is why the very first thing you do in the morning is you pay yourselves first. And if you invest the time learning something, that's going to get you to the next stage. Then you can spend the rest of the time working for somebody else, right? And that is why morning hours are so precious for me, right? So wake up an hour early, 2 hours early. That is the investment. That is where you say that you care about yourself, because there's nobody else who cares about you more than you do. And that's why it's important to do that, I think.
All right, I think we can go on like this, but with limited time, and I'll. Do we have some time left or for any open questions? One question. One question from me. Anyone? Go ahead, Prakash. A bit louder.
Okay. Hello. Okay, right. So there's a lot of emphasis on immutability right now, right? So when we are programming, we say that there are a lot of features in languages which allow us to write immutable programs, right? But at the same time, when you talk about databases, they are still mutable, right? So what do you think? Are we sort of going in the direction where we can say that even database can be immutable, right? So can we sort of perceive a database as a value? Because right now, this is what we sort of try to do. We try to have value-oriented programming, right? We try to sort of minimize the references, right? Minimize the overall shared state and try it with immutable values. So can we sort of go in the direction where we can say that even databases can be perceived as a value? One of the things I was sort of reading sort of last week is we work in, so a closure has a database based on it. They call it Datomic, which sorts of works on immutable values. So do you think that can be the sort of general trend even in databases, the immutable state?
I think there are two answers to that question. The first thing is, I'll avoid that question for a minute and take it on a different direction, and then I'll come back and answer your question. So the very first thing is, how do you practically build a system when you It doesn't want me to say the word immutability. Okay. How do you honor the system when you want to, how do you build a system when you are dealing with immutability? Well, I want you to think about what I would like to call as a circle of trust. So you have a little ring, let's say, and then everything inside that ring, I want you to think of the circle of purity. And so once you enter that ring, you're not going to do any mutation. Now, outside this ring, a very thin circle, we'll call it the circle of impurity. Do your database transactions at that level, the I/O operations, the database operations, logging, reading from files, everything in that circle. So that's one way to build systems without forcing ourselves towards immutable databases. But the other question is, if we do want to have immutable database, is that even practical? Well, you mentioned about Datomic. That's what I was going to mention as well. But let's think about this a little bit differently. We have been using immutable databases for a very long time without even realizing it. Every time you save your code in a source control system, what does your source control system do? What does Subversion do? What does Git do? What does CVS do? They don't go change your file. They make a delta copy, which is immutable, right? And that's the way the word version controls have been working. So the concept of datomic is really very similar to how version controls work. So we have done that for a long time in version controls. The question is, do we want to do that for data? One of the things that concerned us before was that, well, what if we have a limited amount of storage? But that problem has gone, right? Storage is the least problem we have today. But look at the benefits you get out of it. If your data is completely immutable, how easy it becomes to audit, right? You can have audit trails on your database because you're not modifying anything. When an audit has to be done, it becomes extremely simple. I work with some clients where nothing causes fear to them more than the word audit. Because the federal department would come and do audit. FDA, Federal Drug Administration, does auditing, right? Well, if you're using an immutable database, auditing becomes a lot more easier because by true nature of the technology, you got an audit trail in the database all the time, right? So there are several benefits to it. So that's certainly another direction I think we can go. So, but that doesn't have to be the only direction to go also. I think that's where we have the power to make the decision based on what we are trying to do.